Okay, so this is a case number 2 where the acceleration acting in a downward direction. Now in this case, we're going to consider that the acceleration acting in a downward direction. As a result, as you can see, this body is placed inside the elevator, or the man is standing in the elevator. So now the acceleration acting in upward and downward direction. We know that when the this is basically a weight machine. The reaction by the weight machine on the body is n. As a result, by the body on the weight machine is also n, and we know that the direction mg is also acting. So we can see that here the acceleration now acting in a downward direction, which means that we can say that let's elaborate it. F is equals to weight minus Newton reaction, normal reaction, or you can say tension as well. Yeah. So we know that ma is equals to mg minus n, n. It's very obvious. Normal reaction is equals to mg minus a. Normal reaction is equals to mg minus a. Here you can see that the real weight is greater than the apparent weight, because we have the value that we have gotten here is that it is larger. So here the real weight is more greater than the apparent weight, which means body moving in a downward direction, real weight is more than the apparent weight. You can see here the yeah, so the body moving in a downward direction. So let's discuss with the case number 3 that we need to keep in our mind while dealing with it. So let's see with the case number 3. So let's just erase it. Again move up, then a little down, and that goes on. Okay, nevertheless. Okay, so the third case that we're gonna discuss here, that the acceleration is equal to zero. And when I say acceleration, the one thing that click in your mind is now the body is in rest. No, the acceleration is zero, which means the velocity is equals to constant. Velocity is constant, which body moving with uniform velocity. Right, uniform velocity. Body is moving with uniform velocity. You, you cannot say that the body is in rest because it is in equilibrium position. It is in equilibrium state. You can say that F is equals to weight minus tension, or tension, whatsoever you want to say, you can say it by itself. So I would say that weight is equal to tension. As we know that F is equals to MA is equals to W minus T, weight minus tension. And then we're going to see that putting the value A here. So M, then putting acceleration is equal to 0. We know that 0 is equal to 0, weight minus tension. Weight minus tension. As a result, weight is equal to tension. In a final result, weight is equals to tension. Weight is equals to tension. This is the final result that we have gotten, that weight is equals to tension, which means body moving with uniform velocity. So in the back video, we're going to discuss about the last case, but it needs a little more detail is required there. So we'll discuss in the next video.